What if the ground beneath an entire coastline could vanish in just 4 minutes? Not damaged, not cracked, gone, swallowed by the sea forever. Scientists who have spent decades studying one of the most dangerous faults on Earth just found something that changes everything we thought we knew. And the scariest part? Most people living right on top of it have no idea it's coming. Somewhere off the coast of the Pacific Northwest, hidden nearly a mile beneath the ocean, two massive slabs of the Earth's crust are locked together in a silent, invisible struggle. They have been pushing against each other for centuries, and when they finally break free, it won't just be an earthquake. It will be one of the largest natural disasters in North American history. For years, experts believed they understood the danger. They had models, they had predictions, they thought they knew the worst-case scenario. But newly published research has turned that thinking upside down. The threat, it turns out, may be far bigger, far faster, and far stranger than anyone imagined. This is the story of the Cascadia Subduction Zone, the fault line scientists quietly call the Big One. And what researchers have just discovered about it might be the most important warning the West Coast has ever received. Stretching for about 600 miles, the Cascadia Subduction Zone runs from Northern California, past Oregon and Washington, all the way up to Vancouver Island in Canada. Beneath the waves, the Juan de Fuca plate is slowly diving underneath the North American plate, inch by inch, year after year. Most of the time, this movement is smooth, but not here. At Cascadia, the two plates are stuck, locked together by friction, unable to slide. And that means stress is building quietly, invisibly, every single day. Millions of people live directly above this fault without ever feeling it move. Seattle, lighthouses, fishing boats, and quiet beaches, beautiful places, built on top of a sleeping giant. But that giant has woken up before, and when it does, everything changes in minutes. Geologists have found proof buried in the mud, deep along the seafloor and dug into low-lying coastal marshes. Layers of sand and soil tell a story stretching back thousands of years. Each layer represents a moment when the ground suddenly dropped and salt water rushed in, drowning forests that had stood for centuries. Scientists can count these layers like rings on a tree, and what they found is unsettling. Roughly every 400 to 600 years, Cascadia has ruptured in a massive earthquake. The most recent one happened in the year 1700. We know the exact date because of an extraordinary piece of detective work. Old Japanese records describe a mysterious tsunami that struck the coast of Japan on January 26, 1700, with no earthquake felt beforehand. For centuries, nobody in Japan knew where that wave had come from. Eventually, researchers pieced the puzzle together. A massive earthquake had struck the Pacific Northwest coast of North America the night before, sending a tsunami racing across the entire Pacific Ocean. It reached Japan roughly 10 hours later with no warning at all. That earthquake is believed to have been a magnitude 9 or greater. It's terrifying to imagine. But here's the twist. Scientists don't just study the past to understand history. They study it to predict the future. And that future may be closer and worse than anyone expected. Based on the historical pattern, many scientists estimate there's roughly a 37% chance of a major Cascadia earthquake happening sometime in the next 50 years. That's not a distant abstract risk. That's a real possibility within many of our lifetimes. For a long time, experts pictured a single, terrifying scenario. The entire fault ruptures at once. The ground shakes violently for up to 5 minutes straight. Buildings crumble, bridges collapse, and massive tsunami waves, potentially as tall as 100 feet in some areas, come crashing toward the coast. That alone would be catastrophic. But that wasn't the biggest surprise researchers uncovered. In new research published in 2025, scientists modeling the earthquake found something few people had considered. When the fault ruptures, the coastline itself is expected to physically sink, not metaphorically, literally drop in an instant by as much as 6.5 feet in some areas. Imagine standing on solid ground one moment, and the next, that same ground is more than 6 feet lower than it used to be. Areas that were once dry land could become permanently flooded tidal marsh. Not for a day, not for a season, forever. Researchers examined old evidence from previous Cascadia earthquakes and found the same thing happened before. Dry ground instantly transformed into swampy tidal flats the moment the earthquake struck. Whole landscapes changed in seconds. The frightening part is what sits on top of that land today. Ports, roads, neighborhoods. Entire towns have been built on ground that history shows could drop below sea level in an instant. According to the new study, more than double the number of people, buildings, and roads previously thought to be at risk could actually be affected by this sudden sinking. But that wasn't even the end of it. Just when scientists thought they understood the danger, an accident during an old research expedition cracked open an entirely new mystery. Back in 1999, a research ship was heading out to collect sediment samples from the seafloor near the Cascadia Fault, but something went wrong. A crew member accidentally entered the wrong coordinates. Instead of landing near Cascadia, the ship ended up nearly 60 miles off course, drifting into completely different territory, closer to Northern California. Rather than waste the trip, the scientists decided to take a sample anyway, just to see what was down there. What they pulled up from the ocean floor would eventually help rewrite the story of two of the most dangerous fault systems on the entire West Coast. The sample came from a spot called Noyo Canyon, close to where the Cascadia Subduction Zone actually ends, near the top of another infamous fault, the San Andreas. For decades, most people saw Cascadia and the San Andreas as two separate threats. Cascadia, the megathrust fault capable of magnitude 9 earthquakes, and the San Andreas, the fault famous for causing the devastating 1906 San Francisco earthquake. Different faults, different histories, different dangers. Then investigators uncovered something nobody expected. Analyzing that accidental sediment core, and many more collected since, researchers noticed an unusual pattern buried in the layers. Again and again, coarse sand at the bottom, fading into finer material, and then capped by another rough sandy layer. That kind of pairing is not normal for ocean floor sediment. Normal currents don't create patterns like that. Scientists now believe this strange layering is evidence of two earthquakes happening in extremely close succession. First, Cascadia ruptures. Then, within minutes or hours, the San Andreas fault ruptures too. Our researchers found this same paired pattern repeating again and again, stretching back roughly 3,000 years. In total, they identified 18 separate instances where a major Cascadia earthquake appeared to be, followed almost immediately by a significant quake on the northern San Andreas. And remember that legendary 1700 earthquake, the one that sent a mystery tsunami across the ocean to Japan? Evidence now suggests that same event may have also triggered a major rupture on the San Andreas fault, potentially as powerful as the 1906 San Francisco earthquake that reshaped an entire city. If that connection is real, it means the two most dangerous fault systems on the West Coast may not act alone. They may be tied together, like dominoes waiting to fall. Picture this. Cascadia ruptures first. The ground shakes violently along the coast of Washington, Oregon, and Northern California. Tsunami waves begin racing toward shore, and then before rescue efforts can even begin, the San Andreas fault ruptures too, striking areas from Northern California down toward San Francisco. One expert involved in the research described it as a scenario that could become a multi-state, even international emergency, stretching from San Francisco through Portland and Seattle, all the way north into Vancouver, Canada. For years, people believed the single Cascadia rupture was the true worst-case scenario. This new research suggests that assumption might be dangerously outdated. But here's where the story takes an unexpected turn. Not every new discovery has made things sound worse. Some of it has revealed surprising nuance. Scientists had long assumed that Cascadia contained something called a megasplay fault, a secondary fault branching off the main one, running continuously along the entire 600-mile length of the subduction zone. This kind of fault matters because it can dramatically affect how tsunami waves form. Researchers at the University of Washington set out to map it using a technique similar to a geological ultrasound, sending sound waves deep beneath the seafloor to reveal hidden structures. What they found surprised them. The continuous megasplay fault many expected simply wasn't there. Instead, they found only scattered sections, one near the tip of the Olympic Peninsula, another stretching along the border of southern Washington and northern Oregon. Not one long, connected fault, but broken, separate pieces. And why does that matter? Because the presence, size, and shape of these split fault sections directly affects how quickly and how large a tsunami could form after an earthquake. New evidence suggests that for some coastal communities, tsunami waves may arrive a little slower and be somewhat smaller than the most extreme older estimates predicted. That might sound like good news, and in some ways it is, but experts are quick to point out this doesn't mean the danger has disappeared. It means the danger is more complicated, more localized, and harder to predict with a single blanket estimate for the entire coastline. Some communities might face slightly less extreme tsunami timing than once feared. Others, especially where sudden land subsidence drops the coastline by several feet, could face flooding risks that are actually far worse than older models suggested. So which is it? Better or worse? The uncomfortable truth is both. Cascadia isn't one simple threat with one simple answer. It's a puzzle with many pieces, and scientists are still finding new ones. Now, let's talk about what actually happens when this earthquake strikes, because understanding the science is one thing, understanding the human impact is something else entirely. When the fault finally ruptures, experts believe the shaking could last 3 to 5 minutes. To put that in perspective, most earthquakes people experience last only 10 to 30 seconds. 5 minutes of violent shaking is almost unimaginable if you haven't lived through it. Older buildings not designed for this kind of prolonged shaking could suffer severe damage or collapse. Bridges connecting coastal communities could crumble, cutting off entire towns right when people need to evacuate the most. Power lines could fall. Water and gas lines could rupture, sparking fires that emergency crews may struggle to reach. And that's before the tsunami even arrives. Within minutes of the shaking stopping, or in some places even before it fully stops, massive waves could begin racing toward shore. Unlike tsunamis triggered by distant earthquakes, which can give coastal areas hours of warning, a tsunami generated by a Cascadia rupture would strike some communities in a matter of minutes. For people living right along the coast, there may be no time to receive an official alert, no time to wait for instructions. The ground shaking itself would be the warning, and the only real option would be to move to higher ground immediately. Researchers studying Seattle specifically have found that the city may be even less prepared for an earthquake of this scale than previously. Shaking predicted for a Cascadia event could exceed what many of the city's current building codes were actually designed to withstand. That doesn't mean every building would fail, but it does mean some structures, especially older ones, may face risks beyond what their original designers ever planned for. Then there's the issue of land subsidence, the sudden sinking of the coastline discovered in that 2025 study. This isn't just about immediate flooding during the earthquake, it's about permanent change. Ports that ships depend on for shipping and fishing could end up partially submerged. Roads that connect coastal towns to the rest of the region could become unusable, sitting below the new waterline. Homes built decades ago on land that was safely above. Sea level could suddenly find themselves in a flood zone that never goes away. Researchers have said clearly that this kind of instant land drop has happened before, based on fossil and sediment evidence from earlier earthquakes. The difference now is how much more development sits on top of that vulnerable land compared to hundreds of years ago. So what happens next? What happens after the shaking stops? After the tsunami recedes? After the initial chaos settles? The recovery from an earthquake this size would likely take years, not months. Emergency responders have studied scenarios suggesting that certain regions could be cut off from outside help for an extended period, especially if bridges, highways, and airports suffer severe damage simultaneously across a wide area. Communication networks could go down, hospitals could be overwhelmed, and with the added possibility of a connected San Andreas rupture, emergency resources that might normally be shared between Northern California and the Pacific Northwest could be stretched across multiple disaster zones at the exact same time. This is why scientists say understanding both the size of the disaster and its timing matters so much. It's not only about how big the earthquake could be. It's about how many separate crises could unfold simultaneously, competing for the same limited emergency resources. Despite everything you've just heard, there is one important thing to understand. Nobody knows exactly when this earthquake will happen. It could be next year, it could be in 50 years, it could be in 200 years. Earthquakes don't follow a strict, predictable schedule, and scientists have been very clear about that uncertainty. What has changed isn't the certainty of when, it's the understanding of what. New research keeps revealing more accurate, more detailed pictures of how severe this event could actually be, and how many hidden dangers, like sudden land subsidence and a possible chain reaction with the San Andreas fault, might be layered on top of the shaking and tsunami everyone already worried about. Scientists studying Cascadia aren't trying to create panic, they're trying to close a dangerous gap between outdated assumptions and updated evidence. For decades, models were built on the best available data at the time. But as more sediment cores get pulled from the ocean floor and more advanced mapping technology reveals the hidden structure of these faults, the picture keeps sharpening. And every time it sharpens, we learn the story is more complex than we thought. So where does that leave the millions of people living above this fault today? It leaves them with an uncomfortable truth. The ground beneath some of the most beautiful coastline in North America is fundamentally unstable, shaped over thousands of years by earthquakes most people alive today have never experienced and can barely imagine. The research keeps evolving. Some findings suggest certain risks may be slightly less extreme than once feared. Others reveal that the danger of sudden coastal collapse and the possibility of a domino effect with the San Andreas fault could be far more serious than anyone previously understood. What remains constant is this. Cascadia is not a myth. It's not exaggerated folklore. It's a documented repeating pattern etched into sediment layers, drowned forests, and ancient tsunami records on the other side of the ocean. It has happened before, multiple times. And based on everything scientists currently understand, it will happen again. The question was never really if. It was always when and how bad. And now with new evidence pointing towards sudden land collapse, shifting tsunami timelines, and a possible chain reaction stretching from Vancouver to San Francisco, the answer to how bad may be more complicated and in some ways more alarming than anyone predicted just a few years ago. The Pacific Northwest coastline that exists today, with its ports, its neighborhoods, its roads winding along the water, is standing on borrowed time. Not because of anything anyone did wrong, but because that is simply the nature of the ground it was built upon. Scientists will keep drilling. They'll keep mapping the hidden structure of these faults. They'll keep uncovering new pieces of this as ancient puzzle. And with every discovery, our understanding of the big one becomes a little more precise, even as the picture it reveals grows more unsettling. The Cascadia Subduction Zone has been building pressure in silence for centuries. One day, that silence will break. And when it does, the evidence buried in the mud for thousands of years suggests it will be an event unlike anything most people alive today have ever witnessed. If this story left you thinking differently about the ground beneath your feet, let us know in the comments. Do you think coastal communities are prepared enough for what the research is now revealing? Like this video, if you learned something new today, and subscribe for more true stories the world doesn't talk about enough.